Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about the IUPAC nomenclature, the rules of IUPAC nomenclature, and now we are going to discuss about how to prepare the alkynes. So now we are going to discuss about the methods of preparation of alkynes. So what are those? Let us talk about that. So friends, now we are going to discuss about what are the different methods of preparation of alkynes. So there are a few chemicals from which we could make a particular alkyne. So what are those, and let us talk about that. So starting with the first one, that is, we could prepare alkyne from calcium carbide. The second thing is we could prepare alkyne from vicinal as well as geminal dihalides. That is, the process is overall known as dehydrohalogenation process. So we would write over here as dehydrohalogenation process, and the last one is, that is, we could prepare it from, that is, alkyl tetrahalides. So therefore we could write it as, or this method is basically known as that is dehalogenation process. So now these are the things that we are going to do, and that is, we are going to prepare it from calcium carbide, from vicinal as well as geminal dihalide, and ultimately from alkyl tetrahalides. So let us go on with the first one, that is, how can we prepare a particular alkyne from calcium carbide. So let us talk about that. So starting with the first one, that is from calcium carbide. So calcium carbide has a structure of the following that I am going to represent. That is, this is the structure of calcium carbide. The thing we have to do is we have to make the reaction of calcium carbide with water. So there are 2 moles of water that would be required. So I would write it over in this manner, that is HOH plus, again I am representing, because I am using 2 moles of that is water molecule. So that is what I have written over here. So when calcium carbide is being treated with that is water, so the process would take place in such a manner that this calcium will take away both the hydroxyl groups so as to form, that is, CaOH twice, while the remaining part that has been with us is basically this 2 carbon atoms along with 1 hydrogen atom will come over here, while the other hydrogen will come over here. So making this molecule to be formed as basically known as ethine. So this is how we can make a particular alkyne from, that is, especially ethine from calcium carbide. So this is how we have could make that is ethine from this chemical. And now let us move on to the next one, that is, how can we prepare a particular alkyne or from, that is, vicinal as well as from geminal dihalide. So let us talk about that. So the second is from, I'm talking about the geminal dihalides as well as the vicinal dihalide. So these are the 2 things that we are going to talk about. Those starting with the first one is vicinal dihalide. So let us talk about that. So let me talk about vicinal dihalide. Vicinal dihalide is nothing but the alkyl halide that have 2 halogen atoms, and which are being attached to the 2 carbon atoms that are being joined to each other. So vicinal dihalides are those alkyl halides in which the 2 halogen atoms are being attached to 2 different carbon atoms, and that 2 carbon atoms are attached to each other. So let me give an example that how does a vicinal dihalide is represented as. The vicinal dihalide is represented as this manner, as I am writing over here. So this is a general representation of vicinal dihalide. As you could see that both the hydrogen atoms are being attached to that carbon atom, which are attached to each other. So they are not attached to the same carbon atom, but they are attached to different carbon atom, and that's the reason that this is called as a vicinal dihalide. And we could prepare alkyne from vicinal dihalide also, and it is a very easy thing to do. So let me introduce you the first example so that we could understand it in a better way. That is, suppose if we have a molecule like this one, that is so this is the molecule that we have, that is, it is known as vicinal dihalide. The reason behind that is the bromine atoms are being attached that is to different carbon atoms, and that two carbon atoms are attached to each other. So this is the vicinal dihalide, and from which what we have to do is we have to make the reaction in such a manner that alkyne should be produced. But this is not a one-step process. This requires a two-step process, and also I'm talking about that how can we do it in by using a single chemical only. But for now, let me represent you that how can we convert this into alkyne. So basically we have CH3, here it is CHBr, and here it is CH2Br. So we have to make this reaction with the process known as dehydrohalogenation. But for dehydrohalogenation, we know that we are using alcoholic KOH. So this is what we will use. So what will happen is, among this thing, the K, that is the potassium, will take away the bromine atom, and that is the OH group will take away the hydrogen atom from here, making the byproducts to be formed as basically KBr and H2O. So the thing that has been left is basically CH3, then CH, because of the bond has been broken from here as well as from an hydrogen, so therefore the double bond would be mentioned over here. So therefore we could write it as CH2, that is the H has been removed from this thing, so therefore only one H has been remaining along with the bromine atom. So this is how we have converted a vicinal dihalide to a that is vinyl halide. So how can we do the next part? Or the next part is, what we could do is we could again use that is alcoholic KOH, but the thing is we are not using alcoholic KOH, we are going to use the different chemical, a chemical that would be very much essential so as to remove the bromine as well as so as to provocate the dehydrohalogenation process. So in this case what we are going to do is, the product that has been formed, it has been reacted with, that is sodamide, and sodamide is nothing but NaNH2. In this thing what will happen is, the sodium atom that will take away the bromine atom, and while talking about the NH2, this NH2 will take away this carbon atom's hydrogen atom so as to produce NH3 as a byproduct. So therefore the byproduct that are been formed in this case is basically NH3 plus NaBr. And the only thing that has been left here is only carbon, while here it will be CH. So therefore the thing that has been left out is CH3, C, triple bond, CH. So this is how we have prepared an alkyne, and the name of this alkyne, and talking about the name of the reactant that we have used, according to the IUPAC name, this one would be the first carbon atom, this one would be the second, and this one would be the third carbon atom, making this to be known as basically 1,2 dibromopropane. So I would write over here 1,2 dibromopropane. While talking about this product that we have got, this is nothing but propyne, or we could call it as prop1-ine. So this is how we have got from a vicinal dihalide. So this reaction is not only required to use that is KOH, and that is the NaNH2, that is the sodamide. So we could also use in the whole reaction the sodamide itself, but we have to use 2 moles of sodamide so as to obtain that is an alkyne. So this reaction can be also obtained by that is double dehydrohalogenation process, and even that could be possible. In that case we will also get that is prop1-ine. So let us talk about the geminal dihalide and how can we prepare an alkyne from a geminal dihalide. So let us talk about that. from geminal dihalide. So now let us talk about what is geminal dihalide. So geminal dihalide is an alkyl halide in which it consists of two halogen atoms that are being attached to the same carbon atom. Let me represent the general representation of an geminal dihalide. It could be written as in this form also, that is R CH2 So this is called to be, that is geminal dihalide. As you could see, that is both the halogen atoms that are being attached to only one carbon atom. But in the previous one, that is in the vicinal dihalide, the both the halogen atoms that were being attached to the adjacent carbon atoms. So that is the thing, they are called to be vicinal dihalide, while this is known as geminal dihalide. And let me take an example of this, and so as to represent that how can we prepare a particular alkyne from a geminal dihalide. So now suppose if we have a molecule like this one, if I am representing it in this way, that is CH3, CH2, this is bromine atoms that are being attached over here, and hydrogen atom is being attached over here. So suppose if this is the molecule that we have, and for which we have to convert it into an alkyne. So the first thing that we have to do is we have to do dehydrohalogenation process, so as to remove the bromine atom, because we don't need bromine atom, so as to convert or so as to obtain a product that is nothing but an alkyne. And so the thing that we have to do is we have to remove the bromine atom. So the bromine atom along with the hydrogen atom would be removed, and that kind of process is basically known as dehydrohalogenation. But the common thing that we know, that this is the reaction that we have did in our previous lecture also, that is in alkenes, where we have used, that is alcoholic KOH, in which basically the potassium atom will be able to remove one of the bromine atom, while the OH, that is the hydroxyl group, that will be removed one of the hydrogen atom from here, or from this adjacent carbon atom. So therefore making the byproducts to be formed as, that is KBr plus OH along with this H to be formed as H2O. So in this case, if you notice that one hydrogen atom will be less if the hydrogen atom is being removed by this OH group. So therefore only one that is hydrogen is being remaining over here. So the product can be written as, this is CH3. Here only one H would be remaining, so therefore CH, and there will be formation of a double bond. Double bond along with one Br and one H is been remaining, so we will write over here in this way, that is CHBr. So this is the same product that we have obtained in during the dehydrohalogenation process of a vicinal dihalide. So the same product has been obtained, and the thing that we have to do is, again we have to introduce this product with NaNH2, that is sodium sodamide, and the method would be the same thing. So therefore we would write this thing here. So now we will use sodamide, and sodamide is the one that we could represent like in this way, that is NaNH2. So in this case, basically the sodium will be able to remove the bromine atom, while the NH2 will be able to remove the hydrogen of this carbon atom. So therefore the thing that is remaining with us is, that is CH3 carbon triple bond, because here it is double bond that is been mentioned, and because of the bromine atom that has been removed from this carbon atom, and hydrogen atom is being removed from this carbon atom. So because of we could say in case of a homolytic fission also, suppose if that happens, then formation of a triple bond would take place over here. So therefore here it is formation of triple bond along with the removal of the byproducts, and the byproducts are basically NABR along with, that is NH3, that is ammonia. So in this case we have got an alkyne, and the alkyne is nothing but the same, that is propyne. So propyne is what we have obtained. While talking about the reactant that we have used, in this case the reactant that we have used is can be named in terms of an IUPAC nomenclature, can be named as 1,1 dibromopropane. So either you do the dehydrohalogenation process of 1,2 dibromopropane, or you do a dehydrohalogenation process of 1,1 dibromopropane, you will get the same product. And after the, again if you do the dehydrohalogenation process by using the sodamide, again you will get the same product. So in this case, that is, we could use both of the alkyl dihalides, and from which we could prepare a particular alkyne. So this is the method that we have talked about. So let me talk about the last process, that is how can we prepare it from an alkyl tetrahalide. So let me talk about that. So the third is from alkyl tetrahalide. So how can we prepare an alkyne from an alkyl tetrahalide? And let me tell you that alkyl tetrahalide can be represented in this form, that is where we could see that the halogen atoms are basically 4, and it is like a geminal dihalide as well as a vicinal dihalide, as we could observe. So therefore from this we could obtain. So the reaction is very much easy to represent, because suppose if I have represented an example like this one, that is CH3 CCH, and here it is suppose bromine atoms or suppose chlorine atoms are there. You could take anyone. So this is the alkyl tetrahalide, and we'll talk about the IUPAC nomenclature also. So the IUPAC nomenclature is very easy to understand. That is, it is 1,1, 2,2 tetrabromo, and the total number of carbon in this case is 3, making this to be called as propane. So therefore the IUPAC name of this is 1,1, 2,2 tetrabromo, and the total number of carbon in this case is 3, making this to be called as propane. So how the reaction will take place? The thing only we have to do is we have to react it with zinc. Yes, we have to react it with zinc dust. So what will happen is 1 mole of zinc is very able to remove 2 moles of bromine atom, and that would be removed as ZnBr2. So therefore, if we use 2 moles of zinc, then obviously we could get 2 moles of ZnBr2 as a byproduct. And the only thing that would be remaining with us is carbon-carbon triple bond alkyne. And the reason behind that is, suppose if we use first time the zinc, then it would be able to remove the 2 bromine atoms, so making a formation of a carbon-carbon double bond over here, or basically we could say it as an alkene would be formed. And suppose if we are using another mole of zinc, then again this bromine would be removed and carbon-carbon triple bond would be formed. So in this case, what we could get is we could get CH3 C triple bond CH, which is nothing but propane. So in this process, what happens is only the halogen atoms are being removed, and in this case, hydrogens are not being removed. But in the previous lecture, hydrogen was also been removed along with the halogen. So that's the name. So that's the reason the name was basically dehydrohalogenation. But in this case, only the bromine atoms are being removed from the alkyl halide, and that's the reason the process is called to be a dehalogenation process. And this is what we have. So we are going to express a few examples also related to this. So this were the few types of the preparations or method of preparation from which we could prepare, that is alkyne. So here are the few questions that we are going to try out, and this is nothing but the preparation of alkyne itself. So the question is as it follows, that we have to prepare, that is but1-ine from alkyline dihalide, alkylidine dihalide and tetrahaloalkanes. So what is this alkyline dihalide? It is nothing but the geminal dihalide. Yes, geminal dihalide is also been called as alkyline dihalides, and from which we have to prepare, that is but1-ine. And this is alkylidine dihalide. This is nothing but the geminal dihalide from which we have to prepare an but1-ine. And talking about the last one, that is we have to prepare but1-ine from tetrahaloalkane. So talking about the first one, that is how can we prepare it from a alkaline dihalide? Let us talk about that also. So starting with the first one, that is it is nothing but the preparation of an but1-ine or preparation of an alkyne from an that is vicinal dihalide. So therefore from vicinal dihalide, that is what we are going to prepare. So this process, the thing that we have to prepare is but1-ine, means a hydrocarbon atom which consists of basically 4 carbon atoms, and even that consists of the carbon-carbon triple bond between carbon number 1 and carbon number 2. So therefore, suppose if this is carbon number 1, this is carbon number 2, 3, 4, then the carbon-carbon triple bond is between carbon number 1 and carbon number 2. So therefore, I will fulfill the valency of the carbon by the hydrogen atoms. So therefore, it would be called as CH2, and now it will be CH3. So this is what we have to prepare, and this preparation should be done from a vicinal dihalide. So the vicinal dihalide should be of with how much carbon atom? Again, the number of carbon atom is not been reduced; it would be the same itself. So therefore, we have to choose a kind of an alkyl dihalide in which basically we could see 4 carbon atoms have been present. So therefore, these are the 4 carbon atoms that I am representing over here. And again, since it is an alkaline dihalide, so or we could say it as a vicinal dihalide. So therefore, it consists of 4 carbon atoms as well as the 2 halogen atoms that have been attached to the corresponding or the adjacent carbon atoms. So therefore, here suppose I would take it as bromine, and here also I would take it as bromine because I am talking about vicinal dihalide, and I will fulfill the valency of the hydrogen atoms as if just like I have represented over here. So therefore, this is the thing from which we have to prepare that is but1-ine. So let me introduce few of the reagents that I'm going to introduce. So this can be done by the dehydrohalogenation process that we know, and even we could use that is first alcoholic KOH, and then later we will use that is sodamide. But even though the reaction can be done with the help of sodamide itself, that is the thing that we have to use 2 moles of sodamide, in which the first mole of sodamide that we are going to use is basically 2 moles of NaNH2 that I am going to use, among which one Na will be able to remove the bromine atom, so therefore to remove it as NaBr, while the NaNH2 will remove the hydrogen atom of the adjacent that is carbon atom, making to be formed as basically NH3. So but since I have used 2 moles of NaNO2, so therefore I would get 2 moles of that is NaBr along with that of 2 moles of ammonia. So this is how I could prepare that is but1-ine from a vicinal dihalide. But what is the name of this vicinal dihalide? It is very much simple to understand that the name of this is 1,2, that is dibromo, and the total number of carbon in this case is basically 4, making this to be called as butane. So if we do the dehydrohalogenation process, then the but1-ine can be obtained by using that is NaNO2, that is sodamide. So this is the first thing that we have did, and now let us move on with the second one. The second one is from that is preparation of an but1-ine from basically geminal dihalide, or commonly known as alkylamine dihalide. And in this case, again, the same thing that we have to prepare is we have to prepare but1-ine that consists of 4 carbon atoms in a straight chain, and the carbon number 1 and carbon number 2 consist of the carbon-carbon triple bond. Here is the valency that has been fulfilled over here, and talking about this is nothing but but1-ine. And this should be prepared from a geminal dihalide, and even the geminal dihalide should consist of basically 4 carbon itself. So therefore, this is the 4 carbon atom that I have mentioned over here. And since it is a geminal dihalide, and the geminal dihalide, as you could see over here, that is the carbon-carbon triple bond is the one that has been observed in the terminal carbon atom, or in the first carbon atom, if in the terms of the name number that if you would get to that thing, then this is the first, second, third and fourth carbon atom. So therefore the geminal dihalide should also be on the first carbon atom. Suppose if the geminal dihalide or the 2 halogen atoms that have been attached to the second carbon atom, so there is a possibility that we could get as but2-ine also as a product. So that should not happen because we need only but1-ine. So that is the reason that we would make a good precaution so as to mention for the both that is the halogen atoms. I am taking the halogen atom as bromine itself. So the bromine will be attached to the same carbon atom over here, and the rest of the thing would be fulfilled by the hydrogen. So therefore this is the hydrogen that is through which it has been fulfilled. Here also it has been fulfilled by hydrogen, and here also it has been fulfilled by hydrogen. So this is the process that we have to do, the dehydrohalogenation process, so as to get but1-ine. So that is the reason I could use either KOH, and then later I will use that is NaNH2, that is sodamide, or either I could use sodamide itself here. So therefore if I am using that is 2 moles of NaNO2, that is NaNH2, then I could obtain that is 2 moles of NaBr along with that of 2 moles of ammonia. So this is how we could obtain but1-ine. But what is the name of the reactant that we have used? The name of the reactant that we have used is basically can be called as 1,1 dibromo, and the total number of carbon in this case is basically 4, so we call it to be as butane. So 1 comma 1 dibromobutane. So this is how we have prepared the second one. So now the last question is remaining. How can we prepare it from a tetrahaloalkane? So let us do that also. That is from tetrahaloalkane, or basically known as alkyl tetrahalide. So again, the thing is, we will only focus on basically of the product that what we have obtained. So the number of product that we have obtained is it consists of 4 carbon atoms, and this is butane. So that is what we will get. But while using that is tetrahaloalkane, and in this case also there is no decrease or increase in the carbon atom. So therefore we will use the product, we will use the reactant which consists of only 4 carbon atoms. So therefore it would consist of 4 carbon atoms, and moreover we could see that it is a tetrahaloalkane. So therefore so formation of haloalkane, through which we could see that an alkyne has been produced, and that also at the position number 1 and position number 2, or carbon number 1 and carbon number 2. So therefore if I make an tetrahalogen arrangement in such a way that the halogen atoms are attached on the carbon number 2 and 3, 4 halogen atoms are being attached. So this would give us basically butane, but we don't need butane, we need butane. So therefore the halogen atoms, suppose in this case, suppose I have introduced Br, and that too also on the first carbon atom, and on the that is second carbon atom over here, that is I have written over here. So in this case I will now fulfill by the hydrogen atom. So therefore the hydrogen atom will be fulfilled here as CH3, CH2. No hydrogen is been required, and only one hydrogen is been required. So in this case basically I have to remove the bromine atoms, and it has nothing to do with removal of the hydrogen atoms. So the only process that we are going to do is, in this case, is dehalogenation. So for dehalogenation we use zinc. So zinc is the one that could be used, and that also should be an alcoholic thing, and we'll heat it. So 1 mole of zinc will remove 2 bromine atoms, so as to form ZnBr2. But if I use 2 moles of zinc, then even this would be removed. So therefore ultimately I'll get 2 moles of ZnBr2 with the formation of butane. So this is how we can prepare the alkyne. So thank you friends for watching this video. I hope you have understood in this video that how and what are the methods of preparation of alkyne, and I hope you have understood this video very clearly. You share this video with your friends, and I hope you'll subscribe the channel also. Thank you so much.